My name is Karina Velasquez Amaya, and today I will be covering Part 1 of Chapter 10 Experiments. What is experimental research? Experimental research is the gold standard of research. Through this, researchers examine cause and effect relationships in either field or laboratory settings. For example, laboratory experiments may be done in labs but may not reflect the real world and has a high internal validity, while field experiments are conducted outside the lab but are high in both internal and external validity, which is rare. Basic concepts: treatment and control groups. Subjects are either placed into treatment groups where they are administered one or more experimental stimulus, or control groups where they are not given a stimulus. For example, patients are given a new drug for dementia with a high to normal dosage, which is treatment groups, while another group of patients are given a placebo, which is the control group. Researchers would compare such experiments to see if there are any differences or if the drug is effective. Treatment manipulation is checked using pretest and pilot tests before experimental studies, while post-tests are conducted after the treatment. This is what is used to help control for the cause within the cause and effect in experimental research. Random selection and assignment. Random selection is drawing a sample from a population or sampling frame so that there is a positive chance of being selected for a sample, while random selection would be when randomly assigning subjects to either experimental or control groups. For example, 10 workers from a company might be selected randomly to be studied, which is selection, and another 10 workers from another company might be randomly assigned to experimental or control groups. Threats to internal validity. History threat, where extraneous or historical effects affect research results. For example, post-remedial math scores improvements would be caused by math preparations at school. Maturation threat, where subjects change. For example, a person might become smarter to understand complex concepts. Testing threat, where pretest can change or affect post-test responses. For example, if someone is given test answers beforehand, they might remember them and repeat them. Instrumentation threat, where changes can be made to pretest and post-test. For example, test scores might be different because of changes that were done, causing tests to be more easier. Mortality threat, where subjects can drop out of studies and results are then affected. For example, if students who scored badly on a math test drop out, then there will only be those who got good test scores. Regression threat, where subjects may score high on a pretest but can score lower on a post-test, which is closer to the mean. Two-group experimental designs. Pretest, post-test, control group design. Subjects are randomly assigned to either treatment or control groups, both take pretest and post-test. The pretest, post-test go through different forms of internal validity threats such as maturation, testing, and regression. Although selection threats are controlled, additional threats may occur. Post-test only group control design. Simpler version of the pretest, post-test, where pretests are not used. Instead, a two-group analysis of variance is made from the post-test scores, making it more reliable in terms of internal validity. Covariance designs. Variables that are not of central importance, but they do control extraneous variables, which allow for a better detection of the effects of independent variables. It is a pretest, post-test control group where the pretest measures focus on the covariates of interest and not the dependent variables. Factorial designs. Each independent variable is a factor, while the subdivision of the factor is a level. Through factorial designs, they help researchers examine the individual effect of the treatments of dependent variable and their joint effect while looking at more treatments rather than one or two. Main effects occur when the dependent variable shows mass differences between multiple of one factor, while interaction effects can occur when the effect of the differences through one factor depends on the level of a second factor.